Question 6, another integration problem. I'm integrating this fraction, the integral of 8 divided by 3x squared minus 7x plus 2 with respect to x. If you're integrating a fraction, you want to think partial fraction decomposition. First, can you factor the denominator? Does 3x squared minus 7x plus 2 factor? And I can determine if it factors if I can multiply the first and last coefficients. 3 times 2 is 6, and find a pair of factors that adds to give me that middle coefficient. Factors of 6 that add to give me 7 are 6 and 1. Factors of 6 that add to give me -7 are -6 and -1. That tells me that it does factor. And in fact, it factors into 3x minus 1 times x plus 2. Notice the -6 comes from 3x times -2. 3 times -2 is -6. The -1 comes from -1 times 1. And -6 and -1 add to give you -7. Okay, so since I can factor the denominator, that tells me that I can rewrite this fraction as a sum of fractions. And that's the process called partial fraction decomposition. So I'm going to take this fraction, 8 over 3x minus 1 times x minus 2, and rewrite it as a sum of fractions, where I'm trying to find those coefficients. So I'm going to write it as a over 3x minus 1 plus b over x minus 2 and solve for a and b. So the first thing I'm going to do is multiply through by that common denominator. That's going to leave me with an 8 here on the left side. And on the right side, the 3x minus 1 will cancel to give me a times x minus 2. Plus, on this last term, the x minus 2 cancels to give me b times 3x minus 1. Then I'm going to work with the right side to simplify and to combine like terms. So if you multiply through by the a and by the b, and then combine like terms, notice that your x terms are going to be a plus 3b, that's x, and your constant terms are a times -2, -2a, and b times -1, -b. So once you identify your like terms, then you're just matching up like terms on both sides. So on the left side here, I don't have any x terms, so my coefficient is going to be a 0. So my 0x is going to be equal to a plus 3bx, and I get 0 is equal to a plus 3b. For my constant terms, 8 on the left side is equal to -2a minus b on the right side. So to solve this, I took the first equation here, 0 equals a plus 3b, and solved it for a to get a is equal to -3b. And then if I substitute -3b in for a on the second equation, I'm going to get 8 equals -2 times -3b. That gives me a 6b minus 1b. 6b minus 1b is 5b. And 8 equals 5b tells me that b is equal to 8/5. And if b is 8/5, I know that a is -3 times b. So -3 times 8/5 gives me -24/5. So my coefficients for my partial fraction decomposition are a is -24/5, b is 8/5. And I can rewrite this integration problem. So I have that same integration problem written as the sum of fractions, where I get -24/5 times 1 over 3x minus 1 plus 8/5 times 1 over x minus 2. And I'm integrating with respect to x. When you integrate a fraction, you get back a log. So when I integrate 1 over 3x minus 1, I get the natural log of 3x minus 1 times 1/3. So again, if you need to, you can make a substitution and let u equal 3x minus 1. And then du is equal to 3x. And when you work that out, you're going to end up with a 1/3 in there. And the negative 24/5 carries along. On the second fraction, when I integrate, I get 8/5 times the natural log of x minus 2, and then I have my constant of integration. So from here, notice that the 1/3 and the 24/5 can cancel. The 3 goes into 24 8 times. I get negative 8/5 natural log of 3x minus 1 plus 8/5 natural log of x minus 2 plus c. And because I have that common coefficient 8/5, I factored it out. And I brought the positive term first, natural log of x minus 2 times minus natural log of 3x minus 1. And then use the quotient rule for logs to combine those into a single log term. 8/5 natural log of x minus 2 over 3x minus 1, and then my constant of integration plus c.